Hey, what's going on, guys? It's Mr. Sanchez here coming at you with another lesson for Algebra 1. Today we'll be covering lesson 5-1, Relations and Functions. Our learning targets for the day are to represent relations and functions using tables, diagrams, and graphs. It is also going to be identify relations that are, oops, forgot to put that word right there, that are functions. All right. So before we even begin, we gotta define some stuff. So take a moment to write down these definitions. All right. So the first thing we're gonna cover is the word relation. Relation is information that can be represented by a set of ordered pairs. All right. So that's gonna look something like this. You're gonna have a braces. That's called a brace, right? So it looks like a squiggly line, but it's called a brace. And for some reason, okay. So it's you do it like that. All right. That's called a brace. All right. And it's gonna be a set of ordered pairs. So this here is an ordered pair, right? So that's an ordered pair. 1 comma 4, 2 comma 3, 6 comma 5. Those are ordered pairs. All right, but what is an ordered pair? An ordered pair shows the relationship between two elements written in a specific order using parentheses notation and a comma separating the two values. Okay, so in ordered pairs in math, the first value is always going to be x. The second value is always going to be y. This is going to be x. This is y. X, y. Sometimes it might be r comma theta, but we're not gonna see that at least until trigonometry. So don't even worry about it. Okay. So for the most part, it's gonna be x, y ordered pairs, right? Where the x value represents where you would be on the x-axis, and the y value is gonna be where you are in the y-axis in a graph. Okay. There are three ways to represent a relation actually. There's two methods. There's a new method we're gonna learn called mapping, and then there's another method called tables and graphs. We're more familiar with those, as they're something you might have already done in previous classes. But for the most part, mapping is gonna be new. So what is mapping? Mapping is a visual representation of a relation in which an arrow associates each input with its output. Now, if you look at our previous relation, it's gonna be 1 comma 4, 2 comma 3, and 6 comma 5. Well, it just so happens that x's, y's, right? X, y, x, y. X is always going to be our input, and y is almost always going to be our output. All right. So these are our inputs. These are our outputs. And let's say we have the order pair 1 comma 4, right? So to map it, we're gonna go from 1 to 4, drawing an arrow. So we're gonna go 1 to 4. To map 2 comma 3, you're gonna go from 2 to 3. Okay, and then to go from 6 to 5, 6 comma 5, you're gonna go from 6 to 5. All right. Oops, sorry about that. Forgot I had an alarm on. All right, and that's basically how you map things. All right, you're just gonna draw the inputs in one group and the outputs in another group, and it's almost always going to be grouped in a circle and arrows going. There might be an exception where you have a group like this, where it's like 1 comma 2 and 2 comma 2, and it'll ask you to map this. There's two ways to show this mapping. You always have your inputs like this, right? And then you can either have your outputs like this, 2 comma 2, where you go like this, 2 to 2. But because we have the same number, we don't usually write it that way. We'll write it this way, 1 comma 2, and then you'll put 2 in just one circle, right? This is our input. This is our output. And then it'll be same thing here, input, output, right? So 1 goes to 2, and 2 also goes to 2. So you could have it that way as well. Okay, so that's the mapping, all right? Just drawing an arrow from X to Y, and it tells you, and then each order code tells you which one, right? So each input, draw an arrow from the first input to an output, okay? Pretty straightforward, right? The next way to write it, the next way to write it, it would be a table where you have your inputs in one column and your outputs in another. All right, so there's gonna be your inputs. This is gonna be your outputs. Okay, and so remember that we're still working with this relationship right here, relation. So it's 1, 4. So you're gonna put 1, 4. 2, 3, right? So you're gonna put 2, 3, and you're also gonna do 6, 5. Where this is X, this is Y, X, Y, right? And you always gotta put them together. That's one of the most important things. So 1 and 4 has to be 1 and 4. 2 and 3 has to be 2 and 3. And then 6, 5 has to be 6, 5. All right. And that's pretty much the basics of it. And then next thing you know, you have to graph these. That's another way to represent a relation. And so it's pretty straightforward. All right. So we're gonna first graph our first point, which is 1, 4. Okay. So you're gonna go 1, right? On the x-axis, this is x and this is y. In case you don't know. So we're gonna plot these points. X, Y. So we're gonna go where 1 is on the x-axis. So this is the first point, and then we're gonna go to 4. 1, 2, 3, 4. So our point's gonna be right here. And you don't really have to draw these lines here. That was just me to help show you guys what it looks like. Oops. All right. So this is 1, 4. My pencil's not writing. Okay, so 1, 4. The next point to find would be 2, 3. So 2 is right here, and 3 would be right here. So this is 2, 3. Right, and then the last point would be 6, 5. So we're gonna go all the way to 6 here, and then go all the way to 5 here. And this would be 6, 5. Remember, you always go x-axis first, and then you go x-axis, and then go up for the y-axis, and your point's gonna be right there. You do not need to draw the little loop-de-loop. That's another way to represent a function. All right, and you need to know how to represent, a relation in all those types of ways. And you can represent a function the same way you would represent a relation. Okay. Now a function, and the reason you can do that is because a function is a relation in which each input has exactly one output. Okay. So that's basically it. So that means you cannot repeat your y values. That's basically it. All right. You cannot repeat your x values, right? So each input has exactly one output. Okay, those are the key words. All right. So let's look at this first relationship, right? And let's determine the set as a function. So it's 3, 2, 4, 5, 5, 6. An easy way to determine would be let's draw a mapping of this. It's 3, 4, 5. Right. We're gonna do a mapping. These are our inputs. And it's gonna be 2, 5, 6. These are our outputs. Okay, so that's what we're gonna do. This is for A. All right. So 3 goes to 2, and let's change colors just to help see that arrow better. 4 goes to 5, and 5 goes to 6. All right. So because each of these has exactly one output, this is a function. All right. So this is a function. Ta-da. All right. So we checked that one. All right. Now let's try this next one. All right. Let's try this next one. All right. So the next pair is gonna be 1, 2, 3, and then 2, 2, 2. Right. So since it's 2, 2, 2, 2, all the outputs are 2. We're just gonna write 1, 2 on the outside here. Okay. Now I want you guys to guess: is it gonna be a function or not? All right. So the way we'll check is 1 goes to 2. Okay. 2 goes to 2. And 3 goes to 2. All right. So you'll notice that each input has exactly one output. That output is 2. All right. Because each input has one output, this is a function. Okay. is a function. All right. It doesn't matter that they all go to the same number. Inputs can go to the same numbers, okay? They can go to the same output. Whatever you do, however, your input cannot have two different outputs, all right? So each input has exactly one output. That follows this rule, okay? So now let's try this last one. All right. Now we're gonna try C. Okay. So C is gonna be 1, 1. So they're all 1, so we're just gonna have 1 on the left. Well, no, we have 1 and 2, my bad. 1 and 2. And we're gonna have 4, 5, and 6. Right? So right here it says 1 goes to 4. It says 1 goes to 5, and 2 goes to 6. This here is not a function. Why is it not a function? If you look at our input here, if you look at 1, it's giving us 2 outputs, right? Giving us 4 and 5. So because it's giving us 2 different outputs, we can easily say not a function. Because, and if they ask why, because the input 1 has 2 outputs. Okay, so not a function. And that's basically it for the definitions of functions. Next lesson, we're going to cover domain and range of a function and inputting values of a function. All right. Thank you for listening. All right. If you have more questions, this will, show up to the Zoom meetings. All right. Bye-bye, guys.